Hello everyone, myself Srivalli, working as an assistant professor in the Department of Cybersecurity and Data Science in MLR Institute of Technology. So today the overview of presentation includes Introduction to Logical Equivalence and Truth Table Method. First, let us understand what is logical equivalence. So here, two propositions P and Q are said to be logically equivalent if and only if they have same truth values under all circumstances. So here we need to understand propositions. So basically in the last sessions we have seen the connectives. In the connectives we have seen the variables first, P comma Q. So the variables will be always represented with the small letters P, Q. And here we'll get the statement formula to get the output, that is P or Q. But here we need to understand the propositions. Here not variable, here we have propositions. So proposition is also called as a statement. A statement is nothing but it can be P or Q or P and Q or P implies Q, or it can be anything which is a combination of the variables, two or more variables. So that is proposition, and that propositions I am denoting with capital P and capital Q. So this capital P is nothing but in place of P it can be P or Q, P and Q, P implies Q, or even it can be P by implies Q. So this capital P is nothing but it is not a variable. We need to understand that this is called a statement formula. So in the same way, capital Q is also called as it is a proposition. In place of Q, you can have any formula. P implies Q, P or Q, P and Q, or P by implies Q also. So the definition is two propositions P and Q are said to be logically equivalent. So when they are said to be logically equivalent here, if and only if they have the same truth values. Means if both the two propositions are getting the same truth values, then we can say that they are logically equivalent. So here, if you observe, if P is equivalent to Q, then we can write it as P. This is called the symbol of the logical equivalence, Q. P is logically equivalent to Q, means we'll pronounce it as logically equivalent. Symbolically we will represent it as here two lines and two side arrows. Whereas logical equivalence we have the another representation, that is three lines. So these are the two representations. Either you can represent it in the form of this way or you can represent it in the form of this way. So in the previous session we have seen by implication or biconditional. So biconditional, symbolically we can represent it as one line, two arrows. Implication will represent it as only one side arrow. But here logical equivalence is two lines and two side arrows. So this is a representation of logical equivalence here. And if P and Q are logically equivalent, we also write it as the other representation symbolically logical equivalence is three lines. And we can read it as this representation, either first one or second one, symbolical representation will pronounce it as P is equivalent to Q. So this is logical equivalence here. So we are considering two propositions, capital P and capital Q, and they are said to be logically equivalent if they have the same truth values. And symbolically we will represent as like three lines, or you can also represent it as here two lines, two side arrows. So let us see the next slide here. So this logical equivalence we can represent it in two ways. There are two ways to represent the logical equivalence. One is truth table method and the other one is replacement process. So first let us see the truth table method. So the definition of the truth table method is if m comma n are two compound statements. So here in the previous sessions we have seen what is a compound statement. The types of statements we are having is atomic and the other one is compound statement. So atomic statement means we will be representing with a single variable. Compound statement means, so here we'll have two variables and these two are connected with some connective. It can be AND or implication or by implication. So that means connecting two or more statements, connecting two or more variables here. with the same connective, that is called compound statement. So here if m comma n means, let us suppose here we have m is one compound statement and n is another compound statement. So compound statement means here two variables which are connected with one connective here, that is p and q or p or q. So p implies q, p by implies q, like this. Even n also the same thing. It can be any compound statement. And let us suppose here m comma n are two compound statements, and if the truth values in the last column of m means, if this is a compound statement, will not get the resultant directly. First you need to consider, let us suppose if you am taking p and q, first you will be taking p and next you will be taking q, and also next you will be taking here p and q. So means you will not get directly this compound statement as the last column here. First you have to consider individually p, individually q, next you will be taking this compound statement, and that last column of the truth values, if they are same as compared to the next compound statement, which is called as, here I am considering n. So if both are same, the truth values of both the statements, compound statements are same, then we can say that here this m is logically equivalent to n. So here you can also represent like this, m is logically equivalent to n here. So this is truth table method. So let us take few examples on the truth table method and let us check whether we are getting logical equivalence or not. So let us suppose here we are considering P implies Q, show that P implies Q is logically equivalent to negation P or Q. This is one question here I am considering. So you can consider any questions and you can check. So sometimes the questions will be show that, or sometimes the questions will be like verify whether P implies Q is logically equivalent to negation P or Q. So here this is symbolical representation. From this representation you have to understand that this is a logical equivalent symbolical representation. So not only the symbolical representation, sometimes you can have also the questions will be like the theoretical one, like is logically equivalent to. So like this you will get the questions. So here let us solve this question here. So the question is here, show that P implies Q is logically equivalent to negation P or Q. So let us suppose here, as this is by using the truth table, you have to construct the truth table and you need to check. So P implies Q means first you need to consider the variables P, Q, and here P implies Q. Next we have negation P also. The right hand side also you need to consider, you need to have the truth table, and here negation P or Q. Means here I am considering the total LHS is here M and RHS is I am considering with M. Okay, so here this is P implies Q and this is N is negation P or Q. So now construct the truth table here for P, Q, P implies Q, negation P and negation P or Q. So as we are having two combinations, two variables here, so then you will get true, 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 false, false, true, and false, false. So P implies Q. P implies means what? This is nothing but here this is an implication statement, or we can also call it as a conditional statement. And the truth table for this conditional statement is, if first statement is true and the second statement is false, the resultant value you will get always false, otherwise you will get true. So this is a condition for the construction of the truth table of implication. Now negation P. Negation means what here? So opposite of the statement of P. So if you have true here, you will get false. If you have true, again you will get false. Here we have false, then you will get true. And here you have false, then you will get true. This is negation P. Now this is N statement, negation P or Q. Means for this negation P and Q, you need to apply disjunction. What is the condition of the disjunction here? The construction of the truth table is, here even if one statement is true, the resultant value you will get true. So out of this true and here we have false, then you will get true. and here we have false, and here you have here false, then you will get only false. And here we have true and true, then you will get, here we have true, then you will get true. And here we have false, and here you have true, then you will get here true. Now if you observe this P implies Q and negation P or Q, so we have the same values. The last column of this P implies Q and the last column of negation P or Q, so are looking same here. True, false, true, true, and true, false, true, true. So as we are getting, so let us suppose this as I have considered M here, I have considered this is N here. Then as we have the same truth values in the last column of M and N, then we can say that M is logically equivalent to N. Or we can also write it as symbolical representation, M is logically equivalent to N. So this is like how you need to construct the truth table. So let us consider a few more examples also, so that we can understand very clearly. So second question, let us suppose here I am taking P or Q is equivalent to Q or P. Verify, the question we can write it as here, verify whether P or Q is equivalent to Q or P. So here same, we are getting two variables PQ, and here you need to write P or Q, and here we need to write Q or P. So this is M and this is N. Compound statements. Now construct the truth table for this here. True, 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 false, and here you will get false, true, and here false, false. So P or Q means disjunction here. Both are disjunctions only, whether it is P or Q or Q or P. And the condition for the disjunction is here, even if one statement is true, the resultant truth value you will get as true. So true, true here true. True, false is true. False, true is true. But here if you observe, we don't have any true statement, or both are false statements only, then you will get only false. Now Q or P, so same thing here, true. And here we have true, here also we have true. In the last statement, as we don't have any true statements, then you will get as false only. Now if you observe, this is M statement and N statement, both the values are same here. So in this P or Q, true, 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 false, and here Q or P, true, 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 false. So that's why here we can say that this P or Q is logically equivalent to Q or P. So next one. So here till now we have seen with the two variables. So let us solve one problem with three variables also. So P or Q and R is equivalent to P or Q and P or R. So here the question we can write it as here, show that P or Q and R is logically equivalent to P or Q and P or R. So as we have here three variables, then you will get 2 power 3 is equal to total 8 combinations we will get. So here let us suppose I am considering P and this is Q and this is R. So here we need to find out Q and R to get the M statement first. This is M statement and this is called N statement. So here Q and R, then you have to write P or Q and R. Next here P or Q, P or R. Next total N statement you have to write P or Q and P or R. So let us draw the lines here. So P or Q and R, P or Q, P or R, and the last one this one. Now here let us consider the variables here P, Q, R and write down the truth tables. So here you will get all trues first one, then here you can take true, true, false, and here you can take true, false, true, and here false, true, true. So if you observe here, first three we are considering two true statements and one false statement. Next, let us consider two false statements and one true statement. So, FTF. Next, we have TFF. And at last, you will get all the false statements. All three false statements. So, now, let us find out the Q and R. So, what is Q and R here? End is nothing but here, you need to apply the conjunction between Q and R. So, the rule for conjunction is, even if one statement is false, the resultant truth value will get false. So, here you need to apply for Q and R. So, here, as we don't have any false statement here, you will get only true. And here we have the false statement, you will get false. And here also you will get false. And here we don't have false statement, you will get true. And here you will get false. Next, here also you will get false, false, and false. Means wherever you have, means even if one statement is false, the resultant truth value will get it as false statement. Next here, P or Q and R. Means for P and Q and R, you need to apply the disjunction. So for the disjunction, even if one statement is true, the resultant truth value will get it as true statement here. So here we have true, true. True you'll get. True, false, true. True, false, you'll get true. False, true, you'll get true. False, false, you'll get false. False, false, you'll get false. Next, true, false, you'll get true. False, false, you'll get it as here false statement. So, here if you observe, true, 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 and true, true is here. True, false is true, FT is T, FF is F here, F and F is F, true and false is true, false and false is false. Now, if you observe here, we have the other statements also, P or Q and P or R. So, let us suppose here P or Q is there. So, apply disjunction here, then you will get true, 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 and here next you will get false. So, next we will get here true, true and false. So, here as we have true in first three cases, we are getting true. In the even the fourth case also we are getting true. And the next two cases here, first false and false is there, false. Next FT is there here, true. And here true and false are there, true. FF we have F. So, next apply the disjunction for P or R. So, for this true, you have to apply the disjunction. So, next if you observe here, we have the true statement, true and true is true, true and false is true, true and true is true, and here false and true is true, and false and true here, false and true here, you will get as true, and FF is here, you will get false, and true and false is you will get true, false and false you will get it as false. So, next let us go for P or Q and P or R. Means you need to apply conjunction between P or Q and P or R. So, just apply the end here. Means even if one statement is false, the resultant truth value will get it as false. So, here we don't have any false statements, you will get it as all trues only. Next we have here false, false, and here we will get it as true. Next we will get it as false. Now, just observe this P or Q and R, P or Q and P or R. So, here first four we got true statements. Next false, 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 false. Next true statement, false statement, false statement. So, if you observe in this both the statements, that is M statement and this is N statement, as the truth values are same in the last column of both the statements, then we can consider that here this is called logically equivalence. Means this P or Q and R is logically equivalent to P or Q and P or R. So, next let us go for the another problem here. So, P or P and Q is logically equivalent to P. Show that P or P and Q is logically equivalent to P. So, here you need to consider P and this is Q, P and Q. So, here you need to write P or P and Q. So, if you are getting the last column of this value is equivalent to P value, then we can say that both are logically equivalent here. So, here again construct the truth table as we have two variables. So you'll get true, 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 false, false, true, and false, false. So here, as we have conjunction here, you will get it as true and all the statements are false. Why? Because even if one statement is false, the resultant truth value will get it as false. So next, apply disjunction for P and P and Q. That is, so for this two columns, you need to apply the disjunction. So true, true, false, false. Now just observe here, P column and P or P and Q column. So here true, true, false, false, true, true, false, false. So as we have the same values in both the statements, then we can say that here P or P and Q is logically equivalent to P. So like this, we need to solve logical equivalence by using the truth table method. So what we have discussed today is what is meant by logical equivalence, how to construct the truth table with the logical equivalence. So this is one representation of logical equivalence and the second representation will be discussed in the next class. So by this we'll end the session. Thank you.